Hi everybody. So we're going to be doing 5.4 parallel lines and transversals today. So when a pair of lines is parallel, when a pair of lines are parallel, I don't know, and they are intersected by a transversal, there is going to be special relationships that occur. So in 5.3 we talked about just these terms, so vertically opposite, corresponding, alternate interior, alternate exterior, same side interior, same side exterior, so on and so forth. We've talked about what those are, and today we're going to be looking at specifically what happens to angle relationships when we have parallel lines. So when we had, first off, I think on your notes I make you write what parallel lines are. Okay, so parallel lines, are two lines or more than two lines, just lines that will never meet or intersect or touch at any point. So lines that will never meet, touch, or intersect at any point are what parallel lines are. Now, of course, we're talking two-dimensional geography. So on a page, it gets a little bit more complicated when we get to 3D, but we do not need to talk about that right now. So parallel lines, lines that will never meet, like railroad tracks. So here we can tell already that these two lines are not parallel. They will meet just slightly beyond where this is drawn. Okay, so remember here we have a line segment. If I were to extend these lines, they will meet, even though they don't meet right there. Ergo, not parallel. Now, when I have vertically opposite angles, we know from our last lesson that, so a pair of vertically opposite angles, be for example A and C, that even when we have non-parallel lines, A and C are going to be equal. So when I have vertically opposite angles, it doesn't matter if the lines are parallel or not, they're going to be equal. And same thing here. That's not going to change just because we have parallel lines. So for example, I and L are going to be equal as well because they are vertically opposite. Now, keeping in mind, here we have non-parallel lines, here we have parallel lines. So these headings are going to get lost up here. So when I have non-parallel lines and I look at corresponding angles, so I can take a look here. So here I have angle A and what's corresponding to angle A. So this is top left. So this intersection, top left, is angle E. Now, angle A you can see is acute. Angle E you can see is obtuse. There is actually no relationship here. But if I take a look, when I have parallel lines, and I could grab my protractor out to check. Now, taking a look at angle J, and corresponding would be angle N. Now here I have an obtuse angle and another obtuse angle, and if you grab your protractor out, you'll actually be able to see that this angle and this angle are equal. So any corresponding angles that you check, so K and O, P and L, M and Q, are going to actually be equal. So you're going to see that when our lines are parallel, or if our lines are parallel, we will have equal corresponding angles. If we do not have parallel lines, they will not be equal. That's one of the ways I could tell if my lines are parallel. Are my corresponding angles equal? If they are, I have parallel lines. If they are not, I do not have parallel lines. All right, alternate interior angles. Non-parallel lines, alternate interior angles. So if I'm taking a look at D, alternate interior, so alternate, remember opposite, interior, interior angles, so opposite side of the transversal, and it's still an interior angle will be F, so on opposite sides. Now D and F, this one you can see is obtuse, this one is acute. These two are not going to be equal, not equal. Taking a look here, so M and O, notice how they are acute. They're both acute, and if you take your protractor and measure, you're going to see that they are equal. So N and L will be equal also. So if I have parallel lines, my alternate interior angles will be equal. Alternate exterior, when I have parallel lines, so K and Q, alternate exterior angles, you can see that they look like they're the same size, and you will find if you measure that they are the same size, so they are equal as well. And if you don't have parallel lines, your alternate exterior will not be equal. Now here's where it gets a little bit different. So same side interior angles. So there's no relationship when between my same side interior angles when I have not parallel lines. But when I do have parallel lines, so same side interior, let's take a look at M and N. So you'll notice that one is acute and 1 is obtuse. Now remember, M and O, being alternate interior, are going to be equal, right? So this guy is going to be equal to M. Now if I take a look, I have 180 degrees here on this line. So N and O will be 180 degrees, which means that to figure out N, I could do 180 degrees minus O. But I figured out that O is the same as M. So in order to find N, I could do 180 degrees minus M, which means that if I add M and N together, I'm going to get 180 degrees. So two angles that add together to give me 180, those are supplementary. Okay, so they add to give you 180 degrees. Now here, if I take a look at D and E, I have two obtuse angles, and two obtuse angles are not going to be able to add to give me 180 degrees. So we know that they will not be supplementary if I do not have parallel lines. And then same side exterior angles. So let's take a look at K and P, and it's going to be the same thing. So I know from, for example, either corresponding angles, or I could look at alternate exterior angles, that if I know K, then Q is going to be the same. So 180 minus Q is going to give me P, or 180 minus K is going to give me P. So that means these are going to be supplementary as well. So they will also add to 180. So they're not equal, but they will add to 180 degrees if I have parallel lines. Now, if I don't have parallel lines, they will not be supplementary. All right, next page. Now, I've already been using my angles on a line. So I have, for example, if I have 3 angles or 2 angles, or if I cut this into 4 angles, all of those angles together are going to add to give me however many angles are in a line, which is 180 degrees. So if they add to give me 180 degrees, it means they're supplementary. They are. Okay, so angles on a line are supplementary. So that means that if I look at this example here, angle 1 and angle 2 plus angle 3 is going to give me 180 degrees. If I had this cut into 5 different angles, angle 1 plus 2 plus 3 plus 4 plus 5 will give me 180 degrees. Now, angles in a circle, how many degrees does a circle have? 360. So all of these angles, these 6 angles, will add to give me 360 degrees. And one way that I can say that is smack 360. So the sum of the measures of the angles in a circle is 360 degrees. And it's just a quick way of saying that. So sum of the measures of angles in a circle, smack, is 360 degrees. Okay, so that means angle 1 plus angle 2 plus 3, 4, 5 plus angle 6 is going to give me 360 degrees. So if I'm trying to find, for example, angle 3, all I need to do is, if I know my other angles, is do 360 minus all the other ones that I know to find that angle. So I'm getting into some examples where this is useful. Now state the relationship of the two angles in the diagram that determine x. So keep in mind that you are not using your protractor for these. So you are doing this without measuring, which is good because my drawings are not necessarily going to be to scale. Okay, so you are not using a protractor to figure out what these angles are. You're going to be looking at the relationship and then seeing whether it's going to be equal or supplementary from there. So taking a look at 62 and this x. Now here I have my parallel lines cut by a transversal. Now 62 and x, their relationship is here. I have two exterior angles and they're on opposite sides of the transversal. So these are alternate exterior angles. And I know that alternate exterior angles are, if I look back in my rules, equal. Okay, one way I can tell if I know I have parallel lines here, which I do, is even just kind of taking a look at how the angles look. So here, acute angle, they're going to be equal, not supplementary. So this will also be 62 degrees. So x equals 62 degrees. So alternate exterior, determining x is 62 degrees. Okay, so relationship first. So here's my x, here's my angle. Now taking a look, these are interior angles and they are on the same side of the transversal. So these are same side interior angles. And I know that same side interior angles are going to be supplementary. Okay, I could kind of tell that just by my diagram by, oh, here's obtuse, here's acute. They're not going to be equal. I'm going to have supplementary angles here. So 180 minus 121. And get 59 degrees. So x equals 59, and don't forget your units, degrees. Okay, so relationship, same side interior, and that lets me know that I'm going to have supplementary angles. So this will be 59 degrees. Okay, example number 2, determine the measures of all the angles in the diagram to the right. All right, so if these were not parallel lines, I would not be able to figure out anything down here. So I could figure out that B is going to be 118 degrees because it's vertically opposite, and vertically opposite angles are always going to be equal. Now to figure out A, if I take a look here, I have two angles on a line. So here, this whole line is 180 degrees. So 180 degrees minus 118 degrees, and I get 62 degrees. So I know that A is going to be 62. Now C is across from A. Okay, so vertically opposite, so it will be equal 62 degrees. I also could have looked at this 118, seeing that this 118 and C are also on a line, do 180 minus 118, get 62. I also could have realized, since I already have this 118 over here, that the same thing could be applied. So C and B are on a straight line, so they will add up to give you 180 degrees. They will be supplementary. Now, if these lines were not parallel, this is as far as I could go because I only have this angle here, and I would not be able to figure out anything else over here because if we take a look at our rules, corresponding angles are not going to be equal. You don't really know what they are. Alternate exterior angles will be equal in parallel lines, but they won't be equal in not parallel lines. Now these two lines, you can tell I have meant to be parallel. So we can figure out what these angles are in a lot of different ways. So if I use this 118, I know that this angle D is corresponding and corresponding angles are equal. So this will also be 118. I also could have looked at angle B, which I figured out was 118. Alternate interior angles are equal. So this will also be 118. So there's lots of different ways you can figure this out, you guys. You don't just have to look at one way. There are a bunch of ways you can check if you're right. Okay, so E corresponding to 62. So this will be 62 degrees. Oh, vertically opposite, 62 degrees. Oh, vertically opposite, 118 degrees. So here are all our angles. A is 62 degrees. B is 118 degrees. C is 62 degrees. D is 118 degrees. E is 62 degrees. F is 118 degrees. And G is 62 degrees. So you'll notice that when you have parallel lines, you'll have like two answers repeated over and over. Okay, now in example 3, how this is different is I want to give you a reason. So for this, we just figured it out. There's a bunch of different ways that we could figure it out. We had a bunch of different reasons that we could have used. For this one, you're going to write down a specific one. So find the measures of the labeled angles. So A, B, C, D, E. We don't have to find this unlabeled one or this unlabeled one here. and then we're going to write them in the order that we find them and explain our reasoning. Now, this is going to be important to actually write them in the order that you find them, because the most common mistake I get is not doing it in order. So you just figure all of them out and then you can't remember where you started, and then you use kind of the same reason for two, like you get a circular reasoning kind of problem. So I'm just going to tell you, please write them in the order you find them. So let's actually just start with A. It doesn't matter which one you start with, but let's start with A. Okay. Some you won't be able to find right away, but I've set this up for this example to be able to go A, B, C, D, E. So A. Angle A is vertically opposite to this 121. So I know that angle A is going to be 121 degrees. How I know that? So in my reason, how it works is you will have your angle relationship. We'll go here. And then you have to say to which angle. So the relationship to this 121 degree angle is that it is vertically opposite. And I'm going to be lazy and write vert op because I don't know what that means. Okay. So let's try angle B now. So let's find angle B. So angle B, if I take a look, here I have angle A. This is same side interior to angle A, and therefore will be a supplementary angle. So if I take 180 degrees minus 121, I get 59 degrees. So I know that angle B is going to be 59 degrees. And how I know that is because it is same side interior. So the angle relationship is same side interior. Notice how I'm being lazy, to angle A. Now, notice how I'm saying specifically angle A, not 121, even though A is 121. This is my 121 degree angle. B is same side interior to A, not to this guy. So I'm just trying to be clear in how I am, like which relationship I'm looking at. So this is to angle A. And I know that same side interior is going to be supplementary, but I don't need to write that. I did my work here. It's same side interior to angle A, and I will assume that you know it's supplementary and that you have done your math. Okay. Now, figuring out angle C. Now, the problem with angle C, I can't say that angle C is 50 because this angle right here would be 50, not angle C altogether. So I see that this is acute. This is an obtuse angle. Even if this is not drawn to scale, that's still not correct. Can't do that. So I have to figure out C without looking at this 50. Now, another thing that I can look at instead of the 50 is this 59 over here. So C and B are on a line. Ooh, look at that. Okay, so C and B are on a line, so they will add up to be 180 degrees. So I've already done my work over here. So 180 minus 59 is just going to be 121. Angle C is 121 degrees because it is supplementary. It's on a line. So it's supplementary to angle B. Now, notice how same side interior is supplementary, but I don't say it's supplementary. It's supplementary because it's same side interior. So that's what you would write here. Okay, so writing on a line or supplementary to angle B when you have two angles on a line is fine. Fine with me here. Now, that may not have needed to be my reason. I could have also looked here. So angle C is alternate interior to angle A, so that also could have worked for my reason. So instead of saying supplementary on a line, I could have said instead that it is alternate interior to angle A. Now you don't have to have both reasons, but as long as you had one of those reasons, you would be fine. Okay, so there are different ways that you can figure these out and answer them. I also could have figured out D instead of C there, because I know that angle D is going to be 59 degrees because it is vertically opposite to angle B. And there's other ways I could have figured out D as well. So it did not have to be after C. I could have figured out D first, and it did not have to be specifically because of this. So I could have also said it is same side exterior to the 121 degree angle. So that could have been a reason as well. So just remember, you just need to make sure that you're doing them in order, that you're finding them, and stating the reason why correctly. Okay, last angle to find, angle E. Now, I have a problem because there's not a directly vertically opposite angle to it. Here you can see this is acute, this is obtuse. They're not going to be equal because I'd have to actually cut angle C up into two pieces. So can't do that. But what I do know is this angle. I know that this is 121 degrees. I know that this is 59 degrees. And here's 50. So I know 1, 2, 3, 4 of my 5 angles, which means I can figure out my last one because I know that the sum of the measures of the angles in a circle is going to be 360 degrees. Okay, so I can be doing smack 360. Two angles B, C, D, and the 50. So doing that, so 360 minus 59 degrees, minus 121 degrees, minus 59 degrees again, minus 50 degrees. It's going to equal the same thing as 360 minus adding all these things up. You get 289 degrees. So 360 minus 289 is 71 degrees. So E will be 71 degrees because the sum of the measures of the angles in a circle is 360 degrees. And we have angles B, C, D, and the 50-degree angle to thank for that information. Okay, that should be enough for you to do your assignment, right? Bye.